Okay, let's dive right into this explainer and demystify the, frankly, overwhelming landscape of 2026 RAG, or Retrieval-Augmented Generation architectures. If you've been building AI applications lately, you already know the space has totally fractured into multiple distinct patterns. So we're going to cut through all that noise today and figure out exactly what your enterprise AI actually needs. Because let's be real, choosing the wrong architecture right now doesn't just mean getting slightly worse answers. It literally means burning through your engineering budget for absolutely no reason.
Now I want you to look at this shocking number. State-of-the-art RAG systems, they are hitting a factual accuracy ceiling of just 63%. And honestly, if you're using a basic, straightforward implementation without any of the advanced optimizations, you're looking at a pretty dismal 44% accuracy rate. That's straight from a comprehensive 2024 benchmark. Just think about that for a second. If your AI is only getting the facts right 63% of the time, well, that's just not production ready for most enterprise use cases, is it?
So, this naturally begs the critical question. If basic RAG is failing us, how do we push past this accuracy ceiling without completely bankrupting our engineering budgets? The data makes it super clear that the solution isn't just throwing more LLMs at the problem, or, relying on massive context windows. It's actually about fundamentally rethinking how we retrieve and process information before it ever even reaches that generation phase.
To solve this, we're going to map things out using 6 key areas. We've got 1. The RAG accuracy ceiling. 2. Quick wins with hybrid and re-ranking. 3. Agentic and self-reflective loops. 4. Specialized architectures like Graph RAG and Raptor. 5. Adaptive RAG, which is really the sweet spot. And finally, 6. The data governance bottleneck.
All right, kicking things off with Section 1, the RAG accuracy ceiling. Let's start by establishing the stakes here and exposing the flaws of that naive RAG baseline. When you compare these architectures side by side, it's pretty eye-opening. Jumping from naive to agentic RAG increases your costs by 100 times, and it drastically slows down your latency. Look, naive RAG is incredibly cheap. We're talking 1/10 of a cent per query, and it's lightning fast, taking maybe 100 to 500 milliseconds, but you hit that 44% quality baseline. Agentic RAG, on the flip side, gives you the absolute highest quality, but you're paying up to 10 cents per query and waiting up to 10 seconds for an answer. This makes it absolutely crucial to pick the right architecture for your specific needs, so you don't end up over-engineering a simple chatbot, or worse, under-engineering a complex reasoning agent.
Moving on to Section 2, quick wins, hybrid and re-ranking. Let's see how this builds into the highest ROI sweet spot for most production teams heading into 2026.
So the really crucial point here is that hybrid retrieval bridges this frustrating vocabulary mismatch. You see, dense vector search is fantastic for semantic meaning. It totally gets paraphrasing. But it routinely misses things like exact IDs, acronyms, or specific product codes. Sparse keyword search, using algorithms like BM25, catches those exact terms perfectly, but it totally misses the broader context. So by running both and fusing the results together with reciprocal rank fusion, you make sure you don't miss a vital document just because a user searched for, say, renewal, instead of the exact phrase contract extension.
And this illustrates exactly why this is the new production default. You get a massive 28% jump in precision just by turning on a hybrid retrieval. When you combine this with a cross-encoder re-ranking step, which basically acts as a second-pass precision filter, you're capturing the absolute easiest, highest impact optimizations out there. It really is the sweet spot of cost versus quality, and it handles about 80% of real-world use cases.
Next up, Section 3, agentic and self-reflective loops. We're shifting from simple linear pipelines to the absolute cutting edge of autonomous agents. This is where things get truly intelligent.
Think of naive RAG like a straight pipe. A user asks a question, the system retrieves a chunk of text, and the LLM generates an answer. If that retrieved chunk was garbage, well, that error flows freely straight to the user as a hallucination. Agentic RAG, however, is more like a looping state machine. It actually has the cognitive architecture to critique, grade, and correct its own work before responding. It can quite literally realize, wait a second, this document doesn't answer the question at all? Let me try searching again.
Whether you're using architectures like CARG or self-RAG, the workflow follows these self-reflective steps. First, it retrieves the documents. Then, it uses a reflection token, something like ISRE, checking if the context is relevant, to actually grade that context. If it's good, it generates an answer. After that, it uses another token like ISSU, checking if the answer is supported, to verify the output against the source text. And here's the best part: if a retrieved document is irrelevant,
the system can gracefully fall back to a web search to find supplementary context instead of just making something up. It's a seriously powerful, built-in quality control layer.
All right, Section 4, Specialized, GraphRag and Raptor. Because what happens when standard vector retrieval fails completely because the answer is scattered across a dozen different documents?
This is where GraphRag completely changes the game. Instead of just chunking text and looking for similar vectors, GraphRag extracts entities and relationships during the indexing phase to build this massive knowledge graph. It actually maps out relationships and communities within your data. So when a user asks a really complex question like, how does concept A relate to concept B across our entire document base, the system uses graph traversal to connect those dots, which is something pure semantic search literally cannot do.
Applying the Goldilocks principle here, GraphRag is massive overkill for simple factual lookups. I mean, you don't need a knowledge graph to find out what time the office opens, right? But it is just right for complex cross-document reasoning, global summarization, or deep regulatory compliance analysis. Alongside Raptor, which uses recursive clustering to summarize and reason across massive long-form documents, these are highly specialized tools for highly complex problems. Which brings us to Section 5, Adaptive RAG, the sweet spot. This is really the undisputed best practice for 2026 enterprise systems.
Why pick just one architecture when you can kind of have them all? With Adaptive RAG, an LLM classifier evaluates the complexity of the user's prompt right up front and dynamically routes queries to the correct pipeline. Simple factual questions, they get routed to the cheap, fast, naive RAG pipeline. Moderate queries get the advanced RAG treatment with re-rankers, and only those really complex multi-hop questions get routed to the expensive agentic RAG loops. This ensures you never, ever pay agentic prices or suffer those 10-second latencies for a simple factual question.
Finally, Section 6, the data governance bottleneck. Let's reveal the climactic plot twist that can break every single one of those beautiful, highly engineered AI architectures we just talked about. Research from the data control platform Atlan shows a massive 38% accuracy improvement simply by giving AI agents governed data with proper lineage and business glossary definitions. You see, every advanced RAG technique optimizes the retrieval mechanics, but at the end of the day, your retrieval quality is ultimately bounded by what's actually sitting in your index. If your system pulls up 3 different uncertified definitions of revenue from 3 different tables, your agent's going to fail. It honestly doesn't matter how advanced your routing logic is.
This quote from DigiKey perfectly highlights this point. Atlan enabled us to easily activate metadata, delivering context to AI models. The algorithm simply isn't the real bottleneck anymore. It's the upstream data. The foundational layer matters way more than the algorithmic layer. Even the absolute best retrieval models, even GraphRag or SelfRag, will completely fail if they retrieve uncertified context-free data. They desperately need column-level descriptions, data lineage, and quality scores, so the agent knows exactly what it's retrieving and, more importantly, why it's trustworthy.
So I want to leave you with this final provocative thought to take away. You can build the most advanced adaptive state machine in the world, with perfect hybrid search and recursive chunking, the whole shebang. But if your underlying data lacks enterprise governance, it simply won't matter. Your AI is only ever as smart as the context you provide it. So are you spending all your time tuning algorithms, or are you actually preparing your knowledge foundation?